Electricity does not have to come from a distant power plant. With the right components and a basic understanding of how energy moves through electrical systems, it is possible to generate small amounts of power using relatively simple setups. Many of the principles behind these systems were explored more than a century ago by inventors like Nikola Tesla. His work focused heavily on how electrical energy behaves when magnetic fields, coils, and motion interact. While Tesla worked on very large and complex experiments, the core ideas behind some of his concepts can still be explored today with much simpler equipment. Understanding how a basic generator works is the first step. At its core, a generator converts mechanical motion into electrical energy. When a conductor moves through a magnetic field, electrons inside the conductor begin to move. This movement of electrons creates electrical current. This principle is known as electromagnetic induction. It is the same concept used in large power plants, wind turbines, and portable generators, but the principle itself does not require massive equipment. Even small systems can demonstrate the same behavior. The reason many people never experiment with generators is that the process seems complicated at first. Electrical systems often appear difficult because they involve wires, magnets, coils, and unfamiliar terminology. In reality, the basic structure of a small generator is quite simple. 3 core components are usually involved. A magnetic field. A conductor, often in the form of a coil of wire, and motion that moves one relative to the other. When these elements interact, electrical current can be produced. One way to explore this concept is by building a small generator that uses rotating magnets and a coil of copper wire. Copper is commonly used because it allows electrons to move easily through the metal. When magnets rotate near the coil, the magnetic field passing through the coil changes continuously. This changing magnetic field forces electrons in the wire to move, creating an electrical current. In a small experimental setup, the magnets might be mounted on a rotating disc or shaft. The coil is placed nearby so that the magnetic field passes through it as the magnets move. The faster the magnetic field changes, the stronger the electrical signal produced in the coil. Tesla was deeply interested in how magnetic fields and oscillating currents could interact with coils and resonant circuits. While he worked on far more advanced systems, the basic relationship between magnetic motion and electrical current was central to many of his experiments. In a simple generator inspired by these ideas, the focus is on efficiency and stability. The coil must be wound carefully so that the loops of wire are tight and evenly spaced. This helps the magnetic field interact with the conductor more effectively. The magnets must also be positioned so that their field lines pass directly through the coil as they rotate. Even small changes in spacing can affect how much energy is produced. Another important component is the rectifier. A basic generator often produces alternating current because the magnetic field direction changes as the magnets rotate. If the goal is to charge a battery or power small electronic devices, the electrical signal may need to be converted into direct current. A rectifier performs this function by allowing electrical current to flow in only one direction. In small systems, simple diode rectifiers are often used. The mechanical motion driving the generator can come from several sources. In some experiments, a small hand crank is used. In others, a low-speed motor or a small wind-driven rotor provides the motion. The source of the motion does not change the fundamental principle of operation. As long as the magnets move relative to the coil, electrical energy can be generated. One of the most interesting aspects of working with small generators is observing how changes in the system affect the output. For example, increasing the number of turns in the coil often increases the voltage produced. Stronger magnets can also improve the strength of the magnetic field interacting with the coil. The speed of rotation is another important factor. Faster motion causes the magnetic field through the coil to change more rapidly, which usually increases the electrical output. However, building a generator is not only about producing electricity. It is also about understanding how energy flows through a system. Mechanical energy enters through motion. Magnetic fields transfer that energy through electromagnetic interaction. Electrical current appears in the conductor as a result. This chain of energy conversion is the foundation of most modern power systems. Tesla was fascinated by how these interactions could be improved or extended. He explored ways to increase efficiency, manipulate electrical resonance, and even transmit energy across distance. While those experiments involved large equipment and complex systems, the underlying principles can still be observed in small workshop setups. Building a simple generator is one of the most practical ways to see these principles in action. It turns abstract electrical theory into something visible. and measurable. A small light bulb glowing from a homemade generator can demonstrate the same physics that powers entire cities. The key insight is that energy systems are often easier to understand when they are built piece by piece. Instead of thinking about electricity as something mysterious coming from a wall outlet, it becomes a process that can be observed directly. Magnets move, fields change, electrons flow. Energy transfers from one form into another. This perspective is exactly what many early electrical researchers used when they explored new technologies. They started with simple experiments and gradually expanded their systems as they learned more. Even today, engineers still use this approach when designing new electrical equipment. Small prototypes often lead to larger innovations. Understanding the basic generator is a step toward understanding the entire electrical infrastructure that surrounds modern life. Once the core principles are clear, it becomes easier to explore related systems such as motors, transformers, and wireless energy experiments. Each of these technologies builds upon the same electromagnetic foundations. Tesla's work showed how powerful these principles could become when carefully engineered, and while his largest experiments required significant resources, the core ideas remain accessible. A small generator on a workbench can still reveal how energy moves through magnetic fields and electrical circuits. If you enjoy learning how practical energy systems work and how historical electrical ideas can be explored in simple setups, consider subscribing to the channel. New videos break down real engineering concepts in clear terms so you can understand how modern energy technology operates. You can also check the description for a helpful resource that outlines the basic components often used in small generator builds and similar experimental energy projects.